right, indicator 5 now, and we are getting into tables of proportional relationships. And indicator 5, the learning target, I can identify whether two quantities are proportional from table and from a table or a graph. And so I'm doing tables on this part of indicator 5, and the next lesson I'll be doing from graphs. And I can identify proportional and non-proportional quantities. Okay, so first and foremost, let's quickly talk about, we've got two questions over here, but, how can organizing information in a table help you determine if the ratios between two quantities are equivalent? So remember, tables are for organizing data, and once we organize the information, it becomes very easy for us to then calculate what is the unit rate per item that we are going to be calculating. And that unit rate is going to help us look at tables and see whether items are proportional or not. Okay, so let's go ahead and we can start with the one where we've got this question on the board. All right, and it says that um, Miss Spencer orders pizza for her students, and each pizza costs $7. Okay, so I'm going to go ahead and make a table for this. All right, and I'm going to write this way, and I'm going to put this part as number of pizza, and the bottom is the cost in dollars. Okay, so I'm just going to give some values. Let's say one pizza, two pizza, three pizzas, and four pizzas. Okay, and it says that each pizza is costing $7. So the first one is going to be 7. 2 times 7, 14. 3 times 7, 21. 4 times 7, 28. All right, so I fill it out like this. And then I'm trying to see, is the relationship, or, is it a proportional relationship or not, just by looking at this. Okay, so we are going to compare the cost and the number of pizzas for each number of pizzas as a ratio in the simplified form. Okay, so if I am writing it in the simplified form, I know that I am basically writing unit rate. Okay, and when I am writing unit rate, I'll be able to see that are all the unit rates the same or not. So that means is I am going to just, let me put another row here. And I am just going to write cost per pizza. Cost per pizza. All right. And of course, this is the money amount, so in dollars. So all I'm doing in cost per pizza, I am taking the cost divided by how many pizzas. So 7 over 1, 14 over 2, 21 over 3, 28 over 4. And then I am putting it into the simplest form, for which is what? This is going to be, the cost is how much? $7 here. Cost is again $7. Cost is again $7. And cost is again $7. So I can see that all those costs, the two quantities, are proportional if the ratios comparing them are equivalent. In this table, as you can see, all of the ratios comparing the cost to the number of pizzas are equivalent, and they have a unit rate of $7 for one pizza. All right, so the cost of the order is proportional to the number of pizzas ordered. Okay, so that relationship is proportional. All right, now let's look at the next example. And it's saying the following year, Miss Spencer orders pizza again. In addition to each pizza costing $7, there is now a $2 delivery charge. Okay, so I'm again going to make another table in the same format. And I'm going to add on the part for unit rate also on the same table. Okay, so we have the number of pizza, and we have the cost in dollars, and then we are going to find the unit cost or the cost per pizza and in dollars. Okay, so let's look at this. 1 pizza, 2 pizzas, 3 pizzas, and 4 pizzas. All right, so it was, see, 1 times 7 is 7 plus the $2 delivery charge. That makes this $9. Okay, so this is going to be 9, and then 14 plus 2, that gives me 16. All right, let me write this properly. So 9, 16. 3 times 7, 21 plus the $2. Okay, that gives me 23. And then I have the 4 times 7, which is 28, plus the $2. So that gives me 30. Okay, so now when I am going to find the cost per pizza, this is 9 over 1, which gives me 9. All right, 16 over 2, which is 8. All right, and then I have 23 over 3, and this is going to give me $7.67. And then I have 30 by 4, and this gives me $7.50 per pizza. So as you can see that in this second one, the simplest forms are not in the same proportion. Okay, so if all of the ratios have the same unit rate, then the relationship is proportional. Otherwise, it is not. Okay, so in the second one, it is not a proportional relationship. All right, so let's go ahead and do another problem. And let's say my question is, let's say you are earning $8.50 per hour for babysitting. All right. And so let's see, is this a proportional relationship or not? So I'm going to just erase this. So this was proportional. That is non-proportional. Okay. So let's do another problem. And I just said that you are earning $8.50 per hour babysitting. Okay, let's see if this turns out to be a proportional relationship. So I am going to go ahead, I'm going to make my same table. All right, and I'm also going to put one for the unit rate for this one. Okay, so number of hours, okay, amount earned, and this is dollars. Okay, and then I'm just going to do the unit cost or the unit rate. So 1, 2, 3, and 4. So we are saying $8.50 in 1 hour. So in 1 hour, $8.50. In 2 hours, it's going to be $17. In 3 hours, it's $25.50 because 3 times $8.50. And in 4 hours, I'm going to get 34. Okay. Now, you can check proportionality over here by writing each ratio with the same denominator. The most efficient denominator is 1, which is also the unit ratio. And the relationship between the amount earned in dollars and the hours spent babysitting for each number of hours is shown as, if I do this is going to give me $8.50 over 1. Okay, so this is my for 1 hour. Okay, and this is going to be let's say the dollar over hours. That is my unit rate. Okay, 17 divided by 2 also gives me this. So over 1. So this is like I'm putting it in simplest form basically. 2550 divided by 3, I will again get this. And here again, same. All right. So the relationship is proportional because the ratios between the quantities are equivalent and have a unit rate of $8.50 per hour. Okay. So that's basically what a proportional relationship is. Let's talk about a problem where a ticket agency a ticket agency is charging a $6 service fee for any order. Okay, and each ticket is costing $25 plus a $6 service fee. Okay, so this is $1.25 for each ticket, and then you have a $6 service fee. All right, so let's see what happens when I make a table with this. All right, so I am again going to put it into the 3 sections, and I'm going to write number of tickets, number of tickets, all right, and then I'm going to have the total cost of the order, in dollars, and then over here I'm going to put the unit cost. Okay, so if I have 1 ticket, 2 tickets, 3 and 4, okay, so I have to do 1 times 25. That's basically what this means. 1 times 25 plus the $6, right? So that gives me 31 over here, $31. Same thing here, 2 times 25 for the 2 tickets plus the $6. So that gives me 2 times 25 is 50 plus 6, that is 56. Same thing with 3. I'll do 3 times 25 plus 6 and I get 81, and 4 times 25 which is 100 plus 6, that gives me $106. Okay, so now let's see, are these proportional or not? So what I'm going to have to do is again put the unit rate over here, and I can see that if I do 31 over 1, that's already the simplest form, right? So this rate, $31 for 1. All right, the second one, if I divide 56 by 2, I'm going to get 28 for 1. If I divide 81 by 3, I'm going to get 27 for 1. If I divide 106 by 4, I'm going to get 2650 over 1. Okay, so I can see that because the ratios between the quantities are not the same, the cost of an order is not proportional to the number of tickets ordered. Okay, not proportional to the number of tickets ordered because the unit rate is not the same. Okay, now last thing that I want to talk about is identifying the constant of proportionality. Okay, the constant of proportionality. All right, and what this basically means, like you've learned that two quantities are proportional if the ratios comparing them are equivalent or constant. So the constant ratio is called the constant of proportionality. The constant of proportionality has the same value as the unit rate. Same value as the unit rate. So when I'm saying what is the constant of proportionality over here, okay, it is going to be what? This $8.50, $8.50, $8.50. So it continues with the same, the same number which is repeated, and that is your constant of proportionality. Okay, let's say I'll give you another example for constant of proportionality. Let's say I'm talking about. I'm just going to erase this part. Okay, so let's say creators of a stop motion animation film can film 24 frames per second. Okay, so I'm going to just call this number of seconds. Okay, number of seconds. And then we are talking about, like, I'm going to take 1, 2, 3, 4, and then number of frames. Okay, number of frames. So as I said, 24 frames per second, 24 frames per second. So in 1 second, I have 24. In 2 seconds, I'm going to have 2 times 24, that gives me 48, right? In 3 seconds, I'm going to have 3 times 24, that gives me 72. In 4 seconds, I'm going to have 4 times 24, that gives me 96. Okay, so when I'm looking at this, all my simplest forms, all right, my unit rates in all of them is going to be 24 over 1, right? So look, 24 over 1, 24 over 1, 24 over 1. So what is repeating? It's the 24. Okay, so when I can look at what is the constant of proportionality here, it is going to be 24. And then what is the unit rate? Unit rate is going to be 24 frames per second. 24 frames per second. Okay, but the proportionality, constant of proportionality is going to be 24. Because the constant ratio is 24 over 1, the constant of proportionality is 24, and the unit rate is 24 frames per second. Okay, so once again, this lesson, it's all about looking at your tables, organizing your data in tables, because it makes it very visual. And then after that, to check whether all of the data that you have is going to have the same simplest form or the unit rate. And if they have the same simplest form, they are proportional. All right. If they do not have the same simplest form, it is non-proportional. All right. And then, of course, the constant of proportionality is the number which is exactly the same in the simplest form, that is repeating. All right. Okay. Have a great day, y'all.